Hello, fellow controllers, welcome back to another video of the MATLAB course for beginners. My name is Sergio Castaño, and in today's MATLAB video we're going to see how to create matrices. Yes, matrices are the perfect variables to use in our MATLAB software. If you haven't seen the entire course yet, here's the link so you can watch the entire playlist. You know that all the information we're going to see in this video can be found on the Controlatum acute.com website, which I'll leave the link to in the description of this video. So, let's see how to create matrices in our matrix lab. Let's get started. If you want, you can speed up the video so that the explanation is much faster or more dynamic. Well, friends, we're now inside the MATLAB work environment, and as I said in today's video, we're going to learn how to build matrices within our MATLAB software. So, as an example, we have the following matrix C, which is a 3-3 square matrix, that is, it has 3 rows and 3 columns. We see that this matrix will contain numbers that can be whole numbers or fractional numbers, and we are going to enter it in MALD. Matrices are entered in much the same way as we entered vectors in the last video. We simply create our variable, in this case C, and create the brackets. Inside the brackets, we are going to place the numbers, and we are going to do it the same way we did with the vectors. In each row, we separate them with commas or spaces. And to go down to the next row, we have to do it with a semicolon. So we are going to enter the first row, 2 to 4 and 3 with 3. Let's see that the first row enters here. Here I separated it with a space, but you can also separate it with a comma if you want. It doesn't matter, either one works. Now, to go down to the next row, we place a semicolon and place the entire row. I've already entered the second row, we'll use a semicolon to go down to the next row and we'll enter all the complete numbers. There you go, friends. Here I've already entered this matrix as an example. Now, we simply have to hit enter and we'll see that we've already built our first matrix in MATLAB and, as always, the variable z is stored in word space. Well, friends, MATLAB also offers us ready-made functions to create standard matrices, which in our projects we often simply need to create a matrix quickly. So, MATLAB already has these functions ready-made. For example, we're going to create a matrix M1, which in this case is going to be a square matrix again, 3 rows and 3 columns, a 3-3 matrix, but it's going to be a matrix completely full of zeros. So, we simply place the instruction zeros and in parentheses the number that tells us the dimension of the matrix. So we create the matrix, in this case it's going to be 3-3. And we see that we've created a matrix of zeros. We're going to store it in the variable M1. But we could also create larger matrices. For example, let's say a matrix of dimension 30, an absurdly large matrix. We see that it creates the superger matrix here, all full of zeros. MATLAB also has another function called on, which simply creates a matrix completely full of ones, in this case again a square matrix. So, M2 equals, so the function is on and in parentheses the dimension of the matrix. So we put 3, for example, and it creates a 3-3 matrix all full of 1. Again, I can modify the size, it can be 5 and it creates this matrix of 5, always square, 5 columns and 5 rows. MALDA also has the function to create an identity matrix. The MALDAD function to create the identity matrix is here. And in parentheses we put the dimension of the matrix in this case of 3-3. So let's first put M3 and in parentheses 3. We see then that it created a square matrix of 3-3, which is an identity matrix. Again, I can modify the size of the matrix. It can be 1 of 5-5. Let's quickly see how to create a matrix manually and how we can create predefined matrices within the MLAM work environment. There is another MLAMAB function called the run function, which simply creates a random square matrix, that is, with random numbers. So, I can say, for example, M4 equals a run and in parentheses I tell it the size of the matrix n in this case. For example, I want a matrix of 5. So, it creates a random matrix with random numbers of 5-5. It can be of any dimension you want. It can be 1 of 3, for example, and here it creates a random matrix of 3. If I enter it and type it again, we see that it creates a completely different matrix. It always creates a different, random matrix. We see then that these are different random numbers with which this matrix is filled. We saw then that there are these MATLAB functions to generate matrices. We had already seen then that zeros create a matrix completely full of zeros, but we can also use it to create a matrix that is not square. For example, we place the zeros function and place the number of rows we want. We see that MATLAB itself already shows me here the help that I can simply place a number, which will be a square matrix, or I can place several configurations. We will see that in the help video. So, first I place the number of rows. I'm going to tell it that I want 6 rows, comma, and I'm going to tell it that I only want 3 columns. So, I close it and then it creates the matrix that has 6 rows. We see, it has 1, 2, 6 rows and only 3 columns using the zeros function. In the same way we have the on function that creates a matrix M** n of 1. So remembering that the rows are always entered first, so in this case I'm going to tell it that I want 3 rows and finally comma the number of columns. So I'm going to tell it I want 6 columns, so it will be a matrix full of 1s with 3 rows and 6 columns. And in the same way, the function also creates a matrix M** n of 1s on the diagonal and zeros in the rest. So M simply exists. I enter the number of rows. I'm going to say I want 4 rows and 8 columns. So, I create the 4 rows and 8 columns. And here on the main diagonal, it fills it with 1s, which is the identity matrix. In this case, it is not an identity matrix that is not square. And finally, we are going to see that there is also a function called magic, which is also for creating matrices, which simply creates a square matrix n by n of integers, so that the rows in the column add up to the same. Let's see this. So, in parentheses, we put the dimension. Let's say 3. So I create a 3-3 square matrix, where we see that the first row has an 8, a 1, and a 6, which adds up to 15. The second row has a 3, a 5, and a 7, which also add up to 15. And the last row has a 4, a 9, and a 2, which also add up to 15. So we see that all the rows add up to 15, and we will see that the columns also add up to 15. So the first column has an 8, a 3, and a 4, which add up to 15. The second is 1, 5, 9, which adds up to 15, and the third is 6, 7, and 2, which also adds up to 15. So it is simply a matrix that creates whole square matrices so that the rows and columns add up to the same. And so, you can also generate the dimensions you want. And for example, here I create a 7-7 matrix where all the rows and columns will add up to a value. Okay friends, that's it for the video on how to create matrices in MATLAB. With this, you now know how to create your own matrices in MLA manually, which we saw is very similar to how we did it in the vectors video. We simply separate the columns with commas or spaces and the rows must be separated with semicolons. And always within the grid bracket. Let me know in the comments what you thought of this video, if you have any questions or if you already know how to create your own matrices. We saw that there are several functions that we can use in MLA to quickly create matrices effectively, such as the identity case, which is a very popular matrix that we are going to use a lot in our engineering codes. If you liked the video, give it a like. If you didn't like it, give it a dislike. Share this video with your friends, subscribe to the channel, and we'll see you in the next video. You can follow me on my social networks, subscribe to my channel by clicking on my photo and activating the notification bell. And don't forget to watch the next one.